In order to monitor the amount of steam moving through the reactor, we have thermocouples embedded along the side of the reactor, and we have some on the other side of the reactor, and it's used to add more steam to the top or less, and more steam at the bottom or less, and so we have equal heating throughout the reactor. There's a thermocouple there, but these hoses are used for returning some gas back to the reactor so that we don't over vacuum the reactor with our blower. As we extract the gas from the tank, we maintain an equilibrium in the tank by these return lines going to the top and to the bottom of the reactor. There's a video camera embedded in the top of the reactor tank, and we're able to take real-time videos of what's going on inside the reactor. We have some steam working its way up. This is right after we loaded the reactor, and the material's pretty loose, so some steam is working its way up the injector pipes. We have two pipes going down to mid-depth of the reactor and another one going 2/3 of the way down into the reactor. And we have collectors off to the side of the reactor extracting the gas. Once the steam has made contact with the waste and converts it, then it's extracted and destroyed in the boiler. Over time, the steam has stopped coming up from the top once the material densified. The gas, as it's being generated, is extracted from the tank from these three main collectors. One is from the top of the tank, one's from the middle of the tank, and another one from the bottom of the tank, depending on where the gas is being generated at the time of digestion. The gas is drawn into this water knockout, but we also use it as a gas knockout. We have liquids that come from the bottom of the tank called leachate, and that enters this tank as well, and with the vacuum being applied to it, it pulls the gas out of the liquid so we get better recovery. And then the water from here is discharged from this tank over to the plastic tank and then returned to the boiler. We have a desiccant tank here to help dry the gas so that it will burn better in the generator. Otherwise it comes out very wet because the moisture is the carrier for the gas. The blower system here applies the vacuum to the tank to extract the gas, and the meter, the GEM 5000, is used to analyze the quality of gas coming out of the reactor at any given moment. Then we want to collect the gas. We want to put it through a totalizer so we can measure the amount of gas that we pulled out of the reactor. Now it's at 15,700 cubic feet of gas, and that's over a ton of organic waste that's been converted. And then this gas from here is sent to the boiler and is burned and destroyed in the boiler, and is supplemental fuel for the boiler as well. Now we can either send the gas to the boiler to be destroyed, or we can send it to this white tank, which is an accumulator, to build up some gas pressure and concentration of methane gas before sending it to the generator and operating the generator, which also operates these floodlights, and know the ways of destroying the gas.